In this lesson, we will discuss the various types of aviation fuels and their properties, as well as precautions to take during fueling operations. Additional information on this topic can be found in Chapter 11 of the General Aviation Maintenance Technician's Handbook. The type of aviation fuel, or avgas, used in the majority of reciprocating aircraft engines weighs approximately 6 pounds per gallon, has a nominal heat energy content of 20,000 BTUs per pound, and is required to have a vapor pressure of 7 pounds per square inch or less. Volatility is the measure of a fuel's ability to change from a liquid to a gas. 100 low lead has a vapor pressure of 7 pounds per square inch or less at 100 degrees Fahrenheit. Jet A has a vapor pressure of less than 1/10 of a pound per square inch, and Jet B has a vapor pressure between 2 and 3 psi at 100 degrees Fahrenheit. Vapor pressure is the pressure of a vapor above a liquid required to prevent the liquid from releasing additional vapors. If the vapor pressure of a fuel is too low, vapor lock may occur. If the vapor pressure is too high, the engine may be hard to start, particularly in cold weather. Vapor lock is a condition in the fuel system in which the fuel has vaporized and formed pockets of gas in the fuel, preventing liquid fuel from getting to the engine. Vapor lock can occur when the fuel gets too hot or the aircraft climbs high enough that the air pressure above the fuel drops low enough to allow the fuel to vaporize. The minimum octane rating approved for any engine can be found in the type certificate data sheet for that engine. The octane rating is a measure of the resistance of that fuel to detonation. Some fuels have two octane numbers, such as 100/130, where the first number is the aviation octane rating is that with a lean mixture, the second number is that with a rich mixture. Detonation is an explosive burning of the fuel-air mixture inside the engine cylinder when the mixture reaches its critical temperature and pressure. Detonation causes a rapid rise in cylinder pressure, excessive cylinder head temperatures, and a decrease in engine power. Different grades of aviation fuel can be differentiated by the color of dye added to the fuel. For example, 100 low lead is dyed blue. Pre-ignition occurs when the fuel-air mixture within the cylinder head ignites too soon. It is caused by residual hot spots in the cylinder that may be a small carbon deposit on a spark plug, a cracked ceramic spark plug insulator, or almost any other damage in the combustion chamber. It may occur simultaneously with detonation, and like detonation can cause engine roughness and high engine temperatures. Fueling hoses and valves are often color-coded to identify the type of fuel they are carrying. Isooctane is a hydrocarbon fuel used as the reference when rating the anti-detonation characteristics of avgas. Tetraethyl lead is added to avgas to improve its anti-detonation characteristics. It is, however, poisonous, leaves lead deposits inside engine cylinders that foul spark plugs and cause corrosion. Ethylene dibromide is added to avgas to help remove these deposits. If any reciprocating engine fuel tanks have had turbine engine fuel introduced into them, they, along with all of their associated valves, lines, and strainers, must be drained and flushed. Any reciprocating engine that has been operated while its fuel was contaminated with jet fuel, must have its cylinders inspected for internal damage with a borescope, the engine must be compression tested, and the oil must be changed and the oil filter inspected for contaminants that could result from detonation. The FAA has approved some supplemental type certificates that allow some older aircraft to operate on automobile fuel. There are in general 3 different types of jet fuel in use. Jet A and Jet A1 each weigh approximately 6.7 pounds per gallon and have a nominal heat energy content of 18,500 BTU per pound. Because they have a higher viscosity than avgas, jet fuels more readily hold contaminants. The most prevalent contaminant is water, which exists in 2 forms, dissolved and free water. Free water exists in 2 forms, a water slug, which is a large body of water ranging in size from less than 1 pint to hundreds of gallons, or entrained water, which is water suspended in tiny droplets caused by the agitation of fuel and water slugs. Water-contaminated fuel causes several problems in aviation. 1, it can replace or dilute fuel in combustion chambers, resulting in engine failure. Ice crystals can clog fuel lines and filters, and it supports the growth of microorganisms. The problems created by ice crystals in water-contaminated fuel are reduced by filter heating devices and fuel additives such as Prist, which lowers the freezing point of the fuel. Microorganisms that grow in water-contaminated fuel create 2 main problems. 1, they form a sludge or slime that can foul fuel filters and fuel pumps. 2, they entrap water against the sides of the aluminum fuel tanks, causing corrosion. The fuel additive Prist, which lowers the freezing point of the fuel, also acts to destroy microorganisms which contaminate the fuel. The easiest way to reduce solid contaminants such as rust, scale, sand, and dirt is to limit their introduction into the fuel in the first place. While we may never operate a reciprocating engine contaminated with jet fuel, turbine engines can usually be operated on a limited basis with avgas. The avgas, however, does cause 2 problems when used in turbine engines. 1, the tetraethyl lead in avgas causes deposits to form on the turbine blades, and 2, avgas does not have the same lubricating properties of turbine fuels. If fueling an aircraft using a truck, be sure to park the truck in a manner such that should the brakes fail, it is not likely to roll into the aircraft. Then set the brakes and chalk the wheels. Ensure that a CO2 fire extinguisher is readily available. Ground or bond the aircraft to prevent the likelihood that static electricity may ignite the gasoline fumes. Ensure that all aircraft electrical systems and electronic devices, including radar, are turned off. Additionally, do not carry anything in your shirt pockets that may fall into the fuel tanks. Ensure that we are using the proper type and grade of fuel, and take precautions to reduce the likelihood of the fuel being contaminated by dirt, dust, or other contaminants. Do not fuel an aircraft when there is lightning within 5 miles. Do not fuel an aircraft within 500 feet of operating ground radar. And check the fuel cap for proper installation and security before leaving the aircraft. All fuel tanks on reciprocating aircraft are required to be marked near the filler opening with the word Avgas and the minimum permissible grade of fuel. The capacity of the tanks may not be required by the Federal Aviation regulations, but they may be required by the type certificate data sheet for any particular aircraft. Federal Aviation Regulation 23.973 requires that the fuel tank openings in reciprocating engine aircraft not allow a nozzle used for jet fuel to fit into the opening. When pressure fueling, the maximum permissible fueling supply pressure and the maximum permissible defueling pressure are marked on a placard at the fueling control panel. Aircraft should always be fueled outdoors in well-ventilated areas and never inside a hangar.